that you guys need to do here is please check D12 for grades. So don't forget, today is the last day to withdraw from the class. So if you're not doing well in the class, today is the last day to withdraw. So you get a W in your transcript and it won't affect your GPA. If you withdraw after this class, it will be counted as D or F or whatever grade you get. It will affect your GPA. So make sure you guys, if you feel like you need to withdraw it from today, or the most do it online or do it in person. Your online homework 7.4 is due to Wednesday night. So make sure you guys start working on your homework. So today we will talk about 7.5 here, which we call that as your multiple angles. And also we call it as your subproduct to sum to product. So POS, SPO. So there's a shortcut for this formulas. So there's a lot of formulas in this 7.5 sections. There are double angles, power reducing, half angles, product to sum to product. And as you guys know that in your finals, you are still allowed to bring one piece of front page notes in there. So one front page of notes you're allowed. Like what you did in your previous test. So make sure you guys are allowed to bring one page. And I will recommend you to, this is one of the page, I will recommend you to use it. So you can, if you want to write or print out small or something else you want to do with this, please do so. So your final is only consists of chapter 7.4 and 7.5 and 8. Depends on how much I cover. If I can manage to cover 8.6, I will include 8.6. So 8.6 is the one I want to put question marks on it. So if I can cover it, I will cover it. If I can't cover it, then it's not in your finals. So your final is for sure 7.4, 7.5, 8.1, 8.2, 8.3, 8.4, 8.6. I put question marks. So if I manage to cover 8.6, I will definitely do 8.6. So that is your final in this case. So again, it's not comprehensive. It's only have few chapters in few sections in there. So so the first now we talk about the formulas here. So these formulas are very important, and the name of this formula is also important. The reason why this is called a double angle formula is because all your angles in this case is being double. So so that means that you take an angle and then you multiply it by 2. This is double angle formula. And for sine 2u is 2 sine u cosine u. Where they got this formula of sine 2u is 2 sine u cosine u, we can prove that. In order for us to do a proof of double angle formula, you use the sum of 2 angles. This is what you guys did in 7.4. So in order for you to prove this, sine 2u is 2 sine u cosine u. Is using the sine u plus u. So using 7.4, this is sine u cosine u plus cosine u sine u. And you notice that these two are exactly the same. So when you add them up, you become 2 sine u cosine u. Okay, so this is how they got this sine 2u. Now for cosine 2u, we got 3 forms. One is cosine square u minus sine square u. One is 2 cosine square u minus 1, and 1 minus 2 sine square u. Now this cosine 2u has 3 forms. Which form are you using? It depends on what you want to prove or what you want to solve. If you want everything in terms of sine and cosine, then I recommend you to use the second one. The first one, I'm sorry, this is the first one. If you want everything in terms of cosine, then I recommend you to use the second one. If everything is in terms of sine, then you use the last one. So depends on what you're trying to use it for. So so make sure you guys understand that they all have different meaning behind it. So some students use the wrong one and then they end up doing a lot of work. So where is this cosine 2u come from? Again, to prove cosine 2u, it comes from your addition and subtraction. So it's where it's cosine u plus u. So this is back in 7.4. If you add 2 for cosine, this is actually is cos u times cos u minus sine u times sine u. So this is what you guys learned in the previous section. And cos u times cos u is cosine square u. And then sine u times sine u is sine square u. So this is how you get the first form. Cosine 2u is cosine square u minus sine square u. And then in order for you to get the next form, you just use your Pythagorean identity to substitute sine u to become 1 minus cosine square u. And you will end up with this formula. 2 cosine square u minus 1. And if you want to take the third form, you just need to apply cosine square u with the Pythagorean identity. 1 minus sine square u. So if you apply this, you will get 1 minus 2 sine square u. So this is how you get into there are 3 formulas for cosine 2u for a double angle formula. And so make sure you guys know which one is used. The first one came from the 7.4 additional of 2 angles up. And then the other 2 came from just replacing sine square u and cosine square u using Pythagorean identity. So it's very straightforward type. And then for the last one is a tangent 2u. So for tangent 2u, the formula in this case is 2 tangent u 1 minus tangent square u. So how do you prove this? This is again using the formula of tan u plus u. So 2u is u plus u, and to use the additional formula that you learned in 7.4, this is actually is tangent u plus tangent u 1 minus tangent u times tangent u, because it's u and v here. So here you got 2 of them, you get 2 tangent u. And then this you multiply, you get 1 minus tangent squared. So that's why we get this formula. So this is how we do your double angle formulas, and they're very important. And this is how we prove it. Okay. So what the second formula we have is a power reducing formula. What is a power reducing means you reduce the power. So if you look at this, this is all power 2. And if you look at this, this is all power 1. So this is called a power reducing, means a power 2 to become power 1. Where is this power reducing formula came from? This power reducing formula came from this formula. Okay, so we know that using the double angle formula, cosine 2u is 2 cosine square u minus 1. So so this is the cosine using double angle formula. So if you try to find what is cosine u here, cosine square u. So what do I do here is I add 1 here, and I divide this by 2. So when you do, when you left here, it's become cosine square u. And this one is 1 plus cosine 2u over 2. So this is where you get the power reducing. Cosine square u is 1 plus cosine 2u over 2. And then I also use the other one, which is this one. Cosine 2u is 1 minus 2 sine square u. So in order for me to find this sine square u, I again do the same thing. I subtract 1. And then I divide here with -2. So this will give me sine square u is, now when the negative can be applied to the top, so we will get 1 minus cosine 2u over 2. So the negative will change all the sign to become 1 minus cosine 2u. So that's why you get this what we call as a power reducing formula from this sine square u is 1 minus cosine 2u over 2 and 1 plus. And for the tangent square u, what we do here is we use the quotient rule. So tangent is sine square u over cosine square u. So that means I take this 1 minus cosine 2u over 2 over by 1 plus cosine 2u over 2. And you find out that these 2 and 2 will cancel. So what I left here is just 1 minus cosine 2u over by 1 plus cosine 2u. So this is the formula you get on tangent square u is 1 minus and 1 plus cosine 2u. So all this come from the proving part is very straightforward. It's not that difficult. However, this is something I want to tell you here is proving this is not tough, but proving something else is difficult. So I will tell you I will tell you what's going on here. So this double angle formula and power reducing formula can be used when you substitute u to become 2n theta. That means you can use this for the even angle. This is very important. So example is if you have sine 2u is 2 sine u cosine u, you can actually use this formula for sine 4u, where you will still get 2 sine 2u cosine 2u. Means that you take the 4u and you divide by 2. So 4u become 2u. Same thing happens if you want this to become even angle. So 2, 4, 6, 8, 10, 12, and so on. What you do is instead of using u here, you divide that by 2. If you use 6u, then this will become 3u. If you want to use 10u, then this will become 5u. So as long as you have an even angle, then this backside here will be divided by 2 here. Okay, so this is your multiple angle. Same thing happens here. You can also do that here. However, if you want to do for the odd angles like 3u, 5u, 7u, you cannot do this formula. Means, oh, sine 3u, like what David said, you divide this by 2. So it becomes 2 sine 3u over 2 cosine 3u over 2. This is no good. Okay. Same thing with tangent 7u. Tangent 7u is 2 tangent 7u. You divide this by 2. This is also no good. So make sure, so what you do is if it's an even, you can do it. If it's odd, you cannot do it. So if you have odd angles like 3, 5, 7, 9, you cannot do it. But if you have 2, 4, 6, 8, you can do it. So what happens when you have this 3 and 7 and 5 and 9u here? Then you have to, for these cases, if you have odd cases, this is what you need to do. So when you have sine 3u, sine 3u in this case is sine 2u plus u. And this is where you use your 7.4, which is sine 2u times cosine u plus cosine 2u times sine u. So this is what you did in 7.4 is sine vu times cosine v, right? This is what you guys did in 7.4 plus cos u and then times sine v. So and sine 2u is, we have a formula, we have a double angle formula. So this sine 2u in this case will be 2 sine u cosine u using your double angle formula here. And you're multiplying this with another cosine u. So this cosine u will be squared because we got 2 of them. Plus, now this cosine 2u, if you remember, we got 3 formulas, 1, 2, and 3. Now, since this is in sine, so we want this in terms of sine. So the only one that is in terms of sine is this one. It will be 1 minus 2 sine squared. And then you have to multiply this by sine. Okay. So we want everything in terms of sine. So again, when you look at this one has cosine squared u. So we can use Pythagorean identity to do this. So the Pythagorean identity for this cosine square u is 1 minus sine square u. Now we'll distribute this inside here. So I will get 2 sine u minus 2 sine cube u, because sine and sine square become sine cube. And then I distribute the sine u in this case, minus sine u minus 2 times sine cube u. And what do I do here is combine like terms. I think this is plus, sorry, this is plus because this is addition. So this will give me 3 sine u minus 4 sine cube u. So for sine 3u, your formula in this case is going to be 3 sine u minus 4 sine cube u. This is what happens when you have an odd angles. Since we cannot use some multiple angles to do it, so you have to cut this into this case. Okay, and this is for sine 3u. So now I want you guys to use kind of this example to prove that cosine 3u is 4 cosine 3u minus 3 cosine. I want you guys to prove this. This is something that you will get in my finals here. So I want you guys to prove cosine 3u, prove this identity. This is very important. Okay, try to do this on your own. Again, this is very, very important. The trick here is to use your additional. So to prove this, the trick here is to write cosine 3u as cosine 2u plus u. Because 3u is double 2u plus u. So try to prove this become that. Yep, this is the proving on this case. Something that you will see in my test. So in my test, in my finals, I will call you to prove something like that, which is a lot of work. And this section is a little bit tough. Anyone know what to do? Start first here. If you look at what we did. Let me open something, you can see it here. Prove this. Very important stuff. Anyone know what is cosine 2u plus u using your 7.4? Henry, Kelvin, me, Ethan? What is cosine u plus v is?
Cosine u, cosine v.
So in this case, it's cosine 2u times cosine u, because this is your u and v here, plus or minus? For cosine, we use what?
Plus.
Your sign is always switch around for cosine. So if this is plus, you use minus. This will be sine 2u times sine u. So this is your 7.4 using cosine u plus v was cosine u, cosine v minus sine u, sine v. Now you will look at 7.5. What can we do with this cosine 2u? It's a double angle formulas. So which one of these double angle formula are we applying for this one? The first one, the second one, or the third one?
First one.
Why you pick the first one in this case? Look at your proof here. What is it all in terms of?
Cosine.
Cosine. So we don't want to use the first one. We should use the second one because they're all in terms of cosine. So this will be 2 cosine square u minus 1. Then you times with cosine u minus. Now this, you can also use a double angle formula. But the good news for sine 2u, you only got one choice. So in this case, will be 2 sine u cosine u, only one choice. You don't have a choice here. But then you also need to multiply this with sine u. So this sine u will be squared. Now, if you look at this new form you get, they're all in terms of cosine except him. So you can also change this in terms of cosine using what?
Power reducing.
Not power reducing, Pythagorean identity. That's the one that you guys. So distribute this, what you guys got? You will get 2 cosine 3u minus cosine u, just 1 times it, minus this one we will have 2 cosine u here. And what is the Pythagorean theorem that we have here? What is sine square u in Pythagorean identity? One minus cosine square u. And now we will distribute this. Don't forget the negative 2. This is a negative, it's important. So it's 2 cosine 3u minus cosine u minus 2 cosine u plus 2 cosine 3. So this will become a plus. Then you just need to combine like terms. So these two terms are alike. So you will get 4 cosine 3u. And these two terms are alike. You get negative 3 cosine. So this is how you prove this to become that. This is tough. I didn't say this is easy. So make sure you guys know that this is very important class. If you go to calculus class, make sure you guys know that. We also have a tangent one. The tangent one is a little bit icky to prove, but you can still prove it. Still able to prove it. So for the tangent one, if you want to try to go home and do it yourself, so to prove tangent 3u, because we do sine, right? And we just did cosine. The proving of tangent 3u is 3 tangent u minus tangent square u, a cube u, sorry, that's a cube here, all over by 1 minus 3 tangent square u. This is, so I would recommend you guys to go home and try to prove this. If you search for YouTube, yes, there is a lot. So you just search for proof tangent 3u in YouTube. That is a lot. You can actually watch that. So I would highly recommend you guys to do this because it's something that I will, in your finals, I either will come up this proving, or I will come out this proving, or I come out the sine one, the one that we did early on the previous page. So in your finals, you will get, which is this one, sine 3u. So you got either 3 choices, cosine 3u, which is this one, tangent 3u, which is that one, and then sine 3u, which is this one. So I really want you guys to go home and prove this because it is going to be in your finals, one of this for sure, because you guys doesn't like to do verified identity, because when I create your test, your proving identity is one of the worst one. So so I do recommend you guys to go home and practice this. Yes, this is something that is really big. So that is so that's what happens when you have an odd. Okay, so if you have even, you can use this formula. Once you reach to the odd, you have to use a different formula to do this case. So the next one we're going to talk about is your half angle formulas. What is half angle formulas? Is your angles is cut into half. Okay, your angles is cut into half. Where is this formula comes from? It actually comes from your power reducing. Okay, so as you know that when you have sine, using your power reducing, sine square u is equals to 1 minus cosine 2u over 2. So what do I do is I cut this into 2. Okay. What happens like before, if you cut this into 2, then this follow the angles also will cut into 2. Since I want to just have a sine u2, so I need to get rid of this. So I take the square root of it and put a plus minuses. So what we have in this case is sine u over 2 is plus minuses of 1 minus cosine u over 2, because when you cut this by half, the cosine 2u become u. So that's why you get this formula here. Same thing happens with the cosine one. So you use the power reducing for cosine. So you got cosine 2u equals to 1 plus cosine 2u over 2. So for me, you want it to be half angle. So I cut this into 2. I will cut this into 2. And then I'll take the square root of this to get rid of your square. Don't forget the plus minus. So we will get cosine u over 2 is equals to plus minus 1 plus cosine u over 2. Because this will become cosine u in this case. So that's where you get the middle one. And for the tangent u over 2, if you take these two divide, you will end up with this formula. Now, the hint here is very important. The hint down here is very important. Okay, very, very important. So sine u over 2 and cosine u over 2 has this plus and minus symbol. Now, this plus minus symbol actually depends on what quadrant is u over 2 lies. So what does that mean in this case is, as you remember that in your chapter 6, this is all students take calculus. So you figure out that so if u is in quadrant 4, so quadrant 4 means this quadrant, this is quadrant 4. That means u in this case is between 3 pi over 2 and 2 pi. So quadrant 4 is between 3 pi over 2 and 2 pi. But what happens when you cut this by 2? Okay, so when you cut this by 2, then your angle has to cut by 2. So when you cut by 2, this is pi. This will become 3 pi over 4. So can someone tell me where is 3 pi over 4 and pi located? What quadrant? Where is 3 pi over 4 and pi? 3 pi over 4 and pi is actually found in what quadrant? Quadrant 2. And do you know what happens in quadrant 2? Sine is what? Positive or negative in quadrant 2? Quadrant 2, which one is sine is going to be what?
Positive.
So sine, half angle of this is positive, but cosine for this will become what?
Negative.
Become negative. So you have to be careful with this, because although, so imagine that you got the whole 360. If you cut this by half, you only will become 0 to 1. You will get only to 180. So you back to quadrant 2. So what is this multiple angles formula says is it says that the plus and minus signs that you have here, it depends on what the quadrant u over 2 lies. So if it's in quadrant 4, then if you cut this by half, it will become in quadrant 2. Okay, so be careful with this. This is where a lot of students make mistake here with the plus and minuses. Now the tangent is good because the tangent doesn't have a plus minus symbol, so it's always came up with the correct sign. But for the sine and cosine, because of the plus minuses, you are only allowed to have one of those. Okay, and the last one is the product to sum. What is product to sum means you got two being multiplied, and you can write them as the sum, addition or subtraction. And sum to product is the other way. If you have two addition or subtraction ones, if you can do that as a multiplication. So this is a product to sum and sum to product. This is used a lot when you got questions that involve with if you have two different and they're either they are multiplied or either they are divided. Okay, so this page of formulas is very, very important, and we will do this a lot in this class. Okay, especially in your finals. So I would recommend you are allowed to bring front page of notes in there, and this probably will be the first thing you put in there. And on top, definitely don't forget your addition and subtraction for sine, cosine, tangent. This is also important. So make sure you guys, those are the formulas we use a lot, and there are a lot more formulas in chapter 8. So that's the reason why that I allowed you to bring one page of formulas in there. So make sure you utilize this. The first question is you need to solve the equation. Given us that cosine 2x minus cosine x equals to 0. And again, this question wants us to solve this in between 0 to 2 pi. So majority of the questions that you get here is no longer going to be plus 2n pi. It's going to be one revolution only. That means it's go from 0 to 360 or just 2 pi in this case. So can someone tell me which formula should we use for question 1? Is that a double angle, power reducing, half angle, PTS, or STP? Short form for those. Anyone? For question number 1? There are lots of ways to do this, but your answer is going to be the same. Anyone?
Double angle.
So if you want to use the double angle formula, which one of these is a double angle formula we pick? Definitely this one, right? This one has 2x. It's a double angle formula. But as you look at the cosine 2u, you got 3 of them, right? Which one should we pick for here? Are we using the first formula, the second formula, or the last formula? So we are using the middle one. So why we use this middle one? Why don't we not use the other two? Why we use the 2 cosine square x minus 1? Why? Yes, because if you look at this, they are all in terms of cosine. So we will be using this. We don't use the other two because this is in terms of sine. This is in terms of both cosine and sine. So we just picking this. Now this is a quadratic. So if I rearrange this, this will look like 2 cosine square x minus cosine x minus 1 equals to 0. And I'm still shocked to see that when I rate your test, you guys cannot factor this. You should know how to factor this. So go ahead, factor 2x squared minus x minus 1. This is where I see a lot of you guys doesn't know how, when I grade your test 3. I was like, what? You get into here and then you stop. I was like, no, this is something basic. You should know this. So I want you guys to go ahead, factor 2x squared minus x minus 1. Because this is the same as this one. Yep, go ahead and factor it. And if you doesn't know how to factor this, you better get some help. Anyone, the factor for this?
2 cosine x plus 1 cosine x minus 1.
2 cosine x plus 1 and cosine x minus 1. So for this, you get -2. Yep, this is correct factor. And then you make this equals to 0. So cosine x in this case is -1/2. And cosine x in this case is 1. Okay, so you move them. And then you do the arc cosine. So what is the arc cosine of -1/2? And what is the arc cosine of 1? Do I provide you that unit circle in this finals? Remember the unit circle I give it to you guys in the test 3? The answer is no. I won't provide you any unit circles. So make sure you know what to do with your unit circle here. So again, you're allowed to have 1 page of notes. So this page of notes is going to be packed with lots of goodies, formulas, the unit circle. So does anyone know what is the arc cosine of -1/2? Unit circle.
2 pi over 3.
So that will be negative 1/2 cosine is your x, right? So to get a negative 1/2, it is 2 pi over 3 and also what? 4 pi over 3. So this is 2 pi over 3 and 4 pi over 3. And what about arc cosine of 1? That will be either what? This is only 0, right? So this is your answer in this case. Questions? Questions? Tough. Okay. We'll do number 3 here. Tangent x over 2 minus sine x equals to 0. Number 3. So what formula should we use for this question 3? Double, power, half, product to sum to product.
Half.
Yeah, half. Now, the tangent x over 2, we can do half angle. But again, we got 2 of this. 1 minus this and sine u. So which one should we use? To be more honest to you, between those two, we always use the middle one, the first one. The reason why we pick the first one is because your denominator only has 1 term. So we always pick the first one. So this is actually 1 minus cosine x over by sine x. And minus by sine x. This is equals to 0. Now, these questions, what we have here, because there is a fraction, so this is over 1. So we have to make this the same denominator. So you have to find the LCD. And the LCD in this case is sine x. So we will multiply this by sine x. And we will multiply this by sine x. So what we have in this case is sine x in the denominator, still equals to 0. And we got 1 minus cosine x minus sine square x, because sine x and sine x is sine square x. Now, if you look at the top one, they're mismatching. The reason why I say mismatching is because they're all cos and a sine. So what we need to do is we can transform this into cosine using Pythagorean identity. So what do we have in this case is this will transfer to become 1 minus cosine square x. So what we do here is we will have 2 answers. So we will have 1 minus cosine x. Now this negative you have to distribute. This is one of the mistakes that a lot of students make, is they just write 1 plus 1 minus cosine square x because they forget to distribute the negative. So when you distribute the negative, this becomes -1, and this will become positive cosine square x. And we still get sine x. So what you notice here is your 1 and 1 will cancel out. So what I left here is cosine square x minus cosine x over by sine x. And this is equal to 0. So we will factor the cosine x out because they have a cosine x term. So I will take cosine x over sine x out because sine is in the denominator. So what I left here is cosine x minus 1 equals to 0. So I take cosine x out. So on the top, so I will get cosine x minus 1, and then I'll take sine x. The denominator is sine x, so I just make it sine x. Now we have a quotient here. What's a quotient identity for cosine over sine? That will be cotangent. So this is cotangent x times cosine x minus 1 equals to 0. So now you set them become 0. So cotangent x becomes 0 and cosine x become 1. Now 1, we already did it before. So cosine x is 1, you get 0. So this answer is 0 here. So can someone tell me what is the arc cotangent of 0? Again, you have to use your unit circle to figure it out. What is the arc cotangent of 0? Don't forget, cotangent is cosine over sine, which is x over y. So look at your x over y in your coordinates here. So which one give us 0? Anyone? It's going to be your xy axis here. It is 0, pi over 2, pi, or 3 pi over 2 is one of those. Which one give me 0 here? Anyone? The one that gives you 0 is pi over 2 and 3 pi over 2. So this will be your answer in this case. Pi over 2, 3 pi over 2, and don't forget the zeros that we found earlier on in this question. So this is how we do question number 3, where you will use half angle formula to apply it. Yes, this is tough. I didn't say this is easy. This section is actually a killing section. So that's why I really want you guys to spend a little bit more time here. Next, we talk about here is number 4. We skip number 2, we do number 4. Okay. So how do we do question number 4 in this case? Cosine 2x over by sine 3x minus sine x minus 1 equals to 0. So this is question 4 here. So which one are we gonna apply in this case is since if you look at your denominator, this is sum. So we will use the sum to product, which is this formula here. If you look at this sum to product, we will use number 2 because this is sine minus sine. So the top one, I still have cosine 2x. I'm not using double angle formula here. The reason why is you notice later on. But I'm going to use the sum to product here. So that means this follow. So I will get 2 cosine, add this up. So 3x plus x over 2. So that will become cosine 2x. And then sine u minus b. So now I subtract. So it's 3x minus x over 2. So 3x minus x is 2x. Over x is just, over 2 is x. The reason why I did not do the double angle formula in this case is because the cosine 2x and the cosine 2x will cancel. So this is how we use the sum to product formulas, where you have the subtraction, we use this below. And u in this case is 3x, and v in this case is x. Make sure the one on first one is add, divide by 2, and then subtract by 2. So if I want to rewrite this question, this is because the cosine 2x will cancel. 1 over 2 sine x equals to 1. So I move the 1 over there. Then I multiply this over there. So 1 equals to 2 sine x. So multiply that over there. And I'll divide by 2. And then I do the arcsine. So can someone tell me what is the arcsine of 1/2 using your unit circle? Anyone?
5 pi over 6.
So half in this case, sine is your y, right? So it's pi over 6 and what?
5 pi over 6.
And 5 pi over 6. So these are the two answer in this case. So this is not bad. So again, in your test, I won't come up like question 3, which is a little bit tough, but 1 and 4 is doable. So I will come up something like this. So make sure you guys, when you see something with addition, and yes, you can also use sum to product on number 1 because they are minusing. So it's cost minus cost. So you can do the fourth one. You're still going to get the same answer if you use a double angle formula. So it's very flexible here how you do it. But make sure that when you pick that formula, you stick on that formula. Okay. Now, as you guys know that all this formula that you see here is not always go from left-hand side to right-hand side. Sometimes you can go from right to left. So so don't forget, it can go the other way around. So like for question 5, they already tell you what formula you use. So the question is asking us to use a double angle formula to figure out what is cosine square x minus 1/2. So how do we do question number 5 in this case is you look at the double angle formula, since the question wants us to use this formula, and they will tell you that because this question is going to go right to left, so which one of these match with this side? Is that sine 2u, cosine 2u, or tangent 2u to get him? Looks like cosine 2u is the one, and since this one only have cosine terms, so we will do 2 cosine square u minus 1. But my question is not exactly the same as this. I can change the u to x, that's not a problem. But how can you make this to become him? So you have to either multiply or divide with a number. So can someone tell me what should we do to change this 2 cosine to become 1 cosine and this one to become 1/2? You should take this whole thing, multiply by what? How you make 2 to become 1 and 1 to become 1/2? So you multiply this by 1/2, because when you multiply this by 1/2, you will get the cosine square x minus 1/2. But as usual, know that if you, it's like equation, if you multiply 1/2, this side also has to be multiplied by 1/2. So your answer in this case will be 1/2 cosine of 2x. And please do not cancel this 2 and this 2. You get it wrong, okay? Because this is not the same. Don't cancel this. They're not the potato and carrots. Don't do that. So this is your answer here. So make sure you guys know that the identity that you see here can be manipulated, means you can multiply by a number. So, so you can get it to be the same as what we have. So same thing with question 6. Using the double angle formula. So which formula can we use for this question 6? Sine, cosine, or tangent to u? So this is not sine. So because they have the sine square, again, this is actually is the cosine to u. But this time we will use the last one, 1 minus 2 sine square u. But we have to make this to become 10 minus 5. So we have to take this and multiply by a number. So can someone tell me what number do we multiply here to change the -2 to become a +10 and a 1 to become -5? Anyone?
-5.
So if you multiply this by -5 to get him, so this part also has to be multiplied by -5. So your answer in this case will be -5 cosine 2u or 2x. Because again, class, be careful with your online homework because they use x here. So make sure that you just use x, not u. Okay. And I think your online homework, they want you to put this 2x in the parentheses. I think your online homework wants this in parentheses. Otherwise, they mark you up. So that's how we do question 6. So it's not difficult, but you just need to manipulate it. Okay. So now we are doing this question 7. So this is asking you to find the exact value for tangent, sine 2u, cosine 2u, and tangent 2u. Given us that tangent u is -3/5 and pi/2 is less than u is less than pi. So the first thing you need to tell me here is, by looking at this u here, can you tell me what quadrant is this belongs to? What is this quadrant belongs to? Anyone? You can look at your unit circles. This belongs to quadrant 2. That's between 90 and 180 degrees. Okay, so this quadrant 2. So this is the quadrant 2 triangle looks like. So this is u. Now we can use your SOHCAHTOA to apply here. So can someone tell me what is tangent stands for? What over what? Opposite over opposite over adjacent, right? So which one in, so 3 in this case is your opposite, 5 is your adjacent. So which one is this got negative, the 3 or the 5? This is so important. The 5 has a negative because in quadrant 2 your x-axis is negative. So make sure you guys know this. Okay. And what is your hypotenuse in this case? So a lot of students think it's 4 because we have a triplets, right? 3, 4, 5. Is this correct?
No.
No, because your hypotenuse is longer than 5. So in order for you to figure out what is your hypotenuse, you have to use your Pythagorean theorem. So it's 9 plus 25, and 9 plus 25 is 34. This is 9 plus 35. Okay. So this is your adjacent. So with this, you can tell me what is tangent. You can also tell me what is sine. And you can also tell me what is cosine. Can someone tell me what is sine u in this case and cosine u in this case? Sine u is what over what?
3 over square root 34.
So 3 over root 34. Just leave it like this. You do not need to rationalize this. And cosine u is what?
-5 over square root 34.
So yes, what you guys learned in chapter 6, the SOHCAHTOA, will be used again here. So now the question wants us to find sine 2u. So what we did here is just getting ready all the goodies. Now we can use this to find sine 2u. The formula to find sine 2u is 2 sine u cosine u. So the formula for sine 2u is 2 sine u cosine u. So what do I do is I will replace the sine u and the cosine u over here. So I just replace this one over here and this one. So this is actually is 2 times 3 over root 34 times -5 over root 34. So replace, plug in the formulas. So so you multiply the top. 2 times 3 times -5 is -30. So do not distribute, you just multiply. 2 times 3 is 6, 6 times 5 is 30. When you multiply the roots, you will get exactly 34. If you get exactly the same root, so root a times root a, you get a by itself. So that's why I don't want to rationalize this. It's easy. And then you reduce this. This is -15 over 17. So this is how you find sine 2u. The question also wants you to find cosine 2u. Now, as you know that cosine has 3 formulas to use, and no matter what formula you pick, you still get back the same answer. So I'm going to use the first one, cosine square u minus sine square u. And yes, you can use the other two, doesn't matter with the same. So again, I just substitute my cosine and sine u over here. So square means you square it. So cosine is this. So I take -5 over by square root of 34 and I square it. Minus sine in this case is 3 over square root of 34 and I square it. So this will give me 25 over 34 because square and square root will cancel. This will give me 9 over 34. Again, square and square root will cancel. So what you have in this case is 16 over 34 because they are the same. And you just reduce this to become what? Divided by 2. So 8 over 17. So this is how you do the cosine 2u. And then the last one the question wants you to do is to figure out what is tangent 2u. The formula for tangent 2u is 2 times tangent u over by 1 minus tangent square u. So in order for us to do this, again, you plug it in your formulas. This is, forget, this is the tangent u that we have. Let's give it a question. So it's 2 times -3 over 5 over by 1 minus -3 over 5 squared. So you have to follow the orders of operations. So this one, you just multiply this, you get -6 over 5. This is over 1, so multiply them straight across. This one, when you square the -3/5, this is become +9 over 25. And you subtract it from 1, so 1 take away that, you will get 16 over 25. And then you just divide these two fractions using your calculator. You will get your answer in that case. Okay, so make sure you guys you're allowed to use your calculator in your tests, in the finals, including your scientific graphing calculator. So if you have a graphing calculator, you can use this in your test. Okay, for this finals, you can use both of this. So make sure you guys know how to use your calculator to do this kind of fractions. This is -15/8. And if you do not know how to divide this kind of fractions using your calculator, please talk to me, and it probably would take me, say after class, it probably take me 5 to 10 minutes to teach you how to divide this kind of fractions. Make sure you have a calculator that you have. Anyone have any questions so far in order to us to do double angle formula? So this is called double angle formulas. Okay. Sometimes when you look at your homework in this section, they will tell you what kind of formulas you use. Like this one, you have to use double angle formulas. This one is calling you to use power reducing formulas. This one using half angle formulas. So they will tell you what formula to use here. So make sure you follow what formula they want you to use. Okay. Question 9 is asking us to use the power reducing formula. So you are doing tangent square 2x times with cosine 4 2x. So this is because they are power. So we're gonna use, and you want question 9, they want you to write this all in terms of cosine. Okay, so make sure that they will also tell you sometimes what terms you write in. So it's cosine. So before we use the power reducing formula, we can actually simplify this. Tangent is sine over cosine. So this is actually the sine squared 2x over by cosine squared 2x. And I multiply this with cosine 4 2x. You notice that when you simplify, this 2 can be simplified to become square. So this tangent 4 2x cosine 4 2x can be simplified to become sine 2x times cosine 2x. So usually we will use the basic identity. If you can simplify it, we'll simplify this one before you use your power reducing. Okay, PR, power reducing. Now, if you look at your power reducing formula, you notice that we only got sine squared u is 1 minus cosine 2u over 2, right? This is the power reducing formula. But if you look at this question, your u in this case is replacing by 2x. So what happens when you replace your u to become 2x? So what do you get for this case if you use your power reducing? You will get 1 minus cosine. Now this, it used to be 2u. Now this will become 4x over 2. Okay. Because our u in this case is 2x, and then you have another 2 here. So 2 times 2 will make it 4x. And same thing with the cosine 2u. If you use your power reducing, it's exactly the same as the sign, but you just change the sign. So this is 1 plus cosine 4x over 2. So this is using power reducing. Oops, sorry, my 4 is wrong position. So make sure this 4 is not a power. This 4 is a multiples. Okay. So so the 4 is on the x, not on the power. Now what we do is we will multiply them. So 1 minus cosine 4x times 1 plus cosine 4x. If you void this, you will get 1 and then you got a cosine 4x, and then you got a negative cosine 4x. Again, cosine 4x, negative cosine 4x, they will cancel each other out. But you will end up with a negative cosine square 4x, because cosine 4x times cosine 4x, you will get negative cosine 4x. 2 times 2, you get 4 here. Now, this is where you have to do one more time of power reducing. It's because you will have the square. Okay, so every time when you see square involved, you have to reduce it using the power reducing one more time. So the rest is the same. So this is a cosine. So in this case, we will be using the middle one here, cosine square u. So this will become 1 plus cosine 8x over 2. Okay. Where we get the 8 is because now your u in this case is a 4x. So 2 times 4x, we get 8x. And now we need to simplify this, and you will get your answer here. So, so I will make this as over 2, so that this is all over 2. So this is 2 over 2. So this is 2 all over 4. So this is 2 minus 1 minus cosine 8x. So I distribute my negative. And then 2 minus 1 is 1 minus cosine 8x. And then because this is divide, so this I can multiply this. So this will become 1 minus cosine 8x over 8. So this is your answer for question number 9. Sorry, question number 9. So it's a lot of work. You have to actually apply power reducing twice here to reduce your square to become power 1. And they're all in terms of cosine here. So this is a little bit tough, and yes, practice is something that I'm really highly want you guys to do, and I would recommend you guys to work on your online homework, because this one is a little bit tough. Next, we will do half angle formula. So again, half angle formula is where you cut this by half. So you have to use the half angle formulas to find sine, cosine, tangent of angle 67 degrees and 30 minutes. So you have to find what is sine of 67.5 degrees. Okay, using the half angle formula. Okay, so if you look at the half angle formula, the half angle formula in this case is this, using sine. So sine u over 2 is plus minus square root of 1 minus cosine u over 2. So what we need to do here is to figure out what is u is. So we just take this 2 and make it equal. So u over 2 is equal to 67.5. So you multiply both sides by 2. U in this case, if you take out your calculator, 67.5 times 2, that is what?
135.
135. So we this is the first thing you need to do, is figure out what is u is. If the question did not give us u, they only give you half u over 2. So you just combine, you just compare this. So now we know the u here is 135. Now, can someone tell me what is this 67.5 is? What quadrant it belongs to? (67.5 degrees is in quadrant 1. And for quadrant 1, sine is positive or negative? Sign in this case will be
Positive.
positive. 1 minus, can someone use the unit circle to figure out what is cosine of 135? Where's the unit circle for cosine 135?
Negative square root 2 over 2.
So it's negative root 2 over 2. So this will become positive root 2 over 2. Because the negative will become positive because you got double negative here. So so what we do here is we need to rationalize this again. This one can become 2 over 2. So this is the square root of 2 plus root 2 over 4. The top one is 2 plus root 2, and where I got the 4 from is I take this 2 times 2 here. So I got 4. So this is the sine u over 2. Now, how do we figure out cosine u over 2? It's very easy. It's because if you look at these two formulas, they are exactly the same formula, except the sign here is switched. And we know that in quadrant 1, cosine is still going to be positive. So what you do here is you just take this and you just switch your sign. If this is a plus, you do the conjugate. You do the minus here. So in this case, if you know the sign for the half angle, the cosine of half angle is you perform the conjugate in this case. Become minus, and then make sure you know what quadrant is it. Since this is in quadrant 1, so it's still going to be positive. So this is how we figure out cosine u over 2. And the last thing is to figure out tangent u over 2. For us to do this, you take sine over cosine, because tangent is sine over cosine. So you take this square root of 2 plus root 2 over 4 over by square root of 2 minus root 2 over 4. So you just take this 2 and divide. The good news is they all have square roots and they all have 4 in the denominator. So you can actually cancel the 4. So what you left in this case is 2 plus root 2 on top and 2 minus root 2 on the bottom. And then you take a square root. So this is the tangent piece. So the hard piece is to find the sine u over 2. But once you find the sine u over 2, the cosine u over 2, you just need to do the conjugate and then make sure your sine, what quadrant belongs to. It can be minus, it can be plus, depends on the quadrant here. Quadrant 1, they're all pluses. And then for tangent, you just take the sine over cosine and you divide it. And when you divide this, you find out that your denominator is the same, so you can cancel up. So it's just the whatever you have on the top and the bottom, you just put it down there. So this is how you do your sine, cosine, tangent u over 2 the fastest way. We only use the formula once here, which is doing this formula. You can still use the formula for cosine u and tangent u, but I can tell you that it will take you a bit more longer time to do it than using a shortcut here. The one that I really want to show you is question number 11. But before I start question 11, I want you guys to attendance for so put present in your chat room. So the last question is number 11 here is you have to find what is sine u over 2, cosine u over 2, and tangent u using the half angle formulas. The hint here is tell me what quadrant u over 2 lies. So this is pi over pi less than u less than 3 pi over 2. And cotangent u is in quadrant, cotangent u here is equals to 3. So what quadrant is this belongs to? What quadrant is this belongs to? Anyone? Pi to 3 pi over 2. This is pi. This is 3 pi over 2. What quadrant this belongs to? So this belongs to quadrant number 3. So your triangle for quadrant 3 is this. This is the quadrant 3 triangles. Can someone tell me how you apply cotangent u equals to 3 on this triangle? Cotangent is what over what? If you use your SOHCAHTOA. It will be adjacent over by opposite, right? So this will be your adjacent is 3. And your opposite will be 1. Is this correct?
No.
So why this is wrong, Kelvin? Because
Maybe negative.
Yep, in quadrant 3, both of your x and y values are negative. Okay. In order for us to find your hypotenuse, you use a Pythagorean, a squared plus b squared. So a squared is 9, b squared is 1, so 9 plus 1 is 10. Don't forget, when you square, the negative become positive. So now by looking at this triangles, can you tell me what is the sine u and cosine u is? So what is sine u in this case?
Negative 1 over square root 10.
So negative 1 over root 10, and cosine u is
Negative 3 over square root 10.
Yep. Again, we just leave this, do not rationalize this. Now we need to figure out what happens to the quadrant of u over 2. So what do I do here? I just put this aside. So this is your, so we got your pi is less than mu, u is less than 3 pi over 2, right? So in order for us to have a what quadrant is u over 2 lies? So what do I do is I will divide everything here by 2. So what happens when I divide everything here by 2? You got pi over 2 here. And you got u over 2. And you got what here? 3 pi over 4. Because 2 times 2 is 4. So can someone tell me what quadrant is this belongs to? That is very important, the one that we just did here. Anyone? What quadrant is that belongs to? Use your unit circle if you need to. Anyone? This belongs to quadrant 2. Okay, so between pi over 2 and 3 pi over 2, this is in quadrant 2 here. So now we will find what is sine u over 2 using the half angle formula. It's plus minus square of 1 minus cosine u over 2. Now this plus minus is depending on this quadrant. So can someone tell me in quadrant 2, sine is positive or negative?
Positive.
So this we will still use positive. 1 minus, now what is cosine u? Again, cosine u is found by your SOHCAHTOA here. It's going to be plus a negative root 3 over 10. But since we got a negative, so that 2 negative will become positive. And this is still under square root of 2. Over 2 with all square root here. So this is the same thing we're going to do here. We're going to rationalize this. Root 10, this one can become root 10 over root 10. So this is root 10 plus 3, because this will become root 10. And this is 2 times root 10, because you are multiplying your denominator. And this is all in the square. So what do I do here is I just change this 1 to become root 10 over root 10. And then, so I got 10 plus root 3 here. And then again, because the denominator is the same, so I multiply this. So it is going to be 2 times root 10. And I put a square root on it. So this is how you apply your half angle formulas. Then the question asking us to do the cosine of u over 2. Now, as I mentioned to you that this cosine is exactly the same as your sine, but you need to do the conjugate. So this will become root 10 minus 3 over by 2 root 10. But do not forget that in quadrant 2, cosine is what?
Negative.
Yes. So this is where a lot of students make mistake in my test, is because they forgot to put a negative here. And lastly, to find the tangent u over 2, what do I do here is I take sine over cosine. So sine is this, square root of, and then cosine is that, negative square root of, so this is 2 divided. And you notice that your denominator here is the same. I can cancel it. So these 2 can be canceled. So what I have is a negative, because we got 1 plus 1 negative, root 10 plus 3 on top, over by root 10 minus 3. And then you take the square root and the minus. So this is your tangent of this. Okay, so make sure you know that. These 2 will cancel. So you take the top over the bottom, and this is your tangent u over 2. So this is how we got to do question 11. This is very important. The most important piece is this quadrant, because this quadrant determines what sign to use here, because in quadrant 2, we know sine is positive, but cosine and tangent is negative. A lot of students use this to figure out your quadrant. This is, we don't use this because this is not u over 2. This is just u. Okay, so be careful with that kind. Okay, so make sure you know that, and I'll do a few. I'll do the product to sum and sum to product last 2. So this is the last 2 that we use the product to sum and sum to product, is question number 13. So question number 13 is, I'm going to change this to become x so it can be easier for you guys. So 7 cosine negative 5x sine 3x. The question here is asking us to use the PTS, product to sum. So now you need to use the PTS, but PTS comes with 4 formulas. Which formula should we use for product to sum? Is that number 1? Is that number 2? Number 3? Number 4? So 1 is cosine and 1 is sine. We will do the last one. But before we apply the last one, do you guys still remember what happens to the negative angle for cosine? This is the negative, even out identity. What happens when you have cosine with a negative angle? Do they disappear or it move it up front? It will be disappeared. But what happens if you have sine negative angles? Does it disappear or move it up front? This, you move it up front. So make sure you guys know this even odd identity. So this, since you got the cosine of negative, so this fellow will disappear because the negative for cosine will be gone. So in this case, we will apply this will be applied to that. So the 7 is still there. So this 7 has nothing to do with the formula, only the cosine 5x and the sine 3x. So this will be 1/2 times sine u plus v, means add this one up, you got 8x, minus sine u minus v. So this is again, this is u and this is v. Subtract this, you got 2x. So what you do here is multiply the 7 into the half. So you will get 7/2. And then distribute the 7/2 in there. So your answer in this case is 7/2 sine 8x minus 7/2 sine 2x. Make sure you put parentheses on the 8 and the 2x. And that's your answer. So it's very straightforward when you do the product to sum or sum to product. But make sure you guys know that you can only work for the cosine and sine. This 7 that you have, whatever number in front you see here, is just a duplicate, or just bring it down. So you just multiply it later on. Okay. And the last one is question number 14, is where you use the sum to product. So you have to do cosine of 6x plus cosine of 2x. So we'll be using STP, sum to product. So now you look at your formula for sum to product. Again, you got 4 of them. You only pick one. So this is actually cosine plus cosine. So this is number 3. And this is my u, and this is my v. So for using the formula, it says 2 times cosine u plus v over 2. So that means you take these 2, add them up. So 6x plus 2x over 2. And then cosine u minus v. So you subtract cosine 6x minus 2x over 2. So you kind of plug it into your formula here, and you just do your work. So 6 plus 2 is 8. 8 divided by 2 is 4. So it's 2 cosine 4x. And then you do the same thing. 6 minus 2 is 4. 4 divided by 2 is 2x. And that's your answer. Okay. So it's very straightforward type when you guys use the STP and the PTS. The only thing that you need to watch out here is if this is negative, then make sure you use your even odd identity. That means the negative will disappear here. Okay, so you just need to watch carefully if you got a negative angle or not. For this sign, if they're all positive, you're good to, you have no need to worry about. If they are negative angles, then you use the even odd to either they are disappeared or they bring it up front. So cosine will be disappeared, sine you bring it up front, and tangent also bring it up front. So if you have tangent negative x, just write over here so you can see. So tangent negative x is going to be also negative tangent x. So only cosine that's negative is disappeared, and secant, don't forget cosine and secant are reciprocal. The negative is disappeared. But for the rest of that, sine, cosecant, tangent, cotangent, your negative will be up front. Okay, this is very important. So That's it for today in this section 7.5, which is a lot of work. So make sure you guys study this. This is kind of difficult, but the formula is the one over here. Make sure you know how to plug it in and use it. A lot of practice. So that is something I will encourage you guys to do. All right, so anyone have any questions for me before we end the Zoom meeting? You do have one homework due on Wednesday, which is 7.4. Start doing your homework, and there are a bit more homework on next week and the following week. So make sure you guys start working on your homework. We're almost done there. We've got a couple more weeks left class. If you have questions, do stay. If you have no questions, you may go. Please check D2L for your grades. You did enter your final grades in your test, and everything is in that test grid. If you have any questions, talk to me now.